The question is like this: without using Pythagoras theorem, show that the points, these 3 points, are the vertices of right angle triangle. So how can we show that these 3 vertices form a right angle triangle without using Pythagoras theorem? So it is like this, that suppose this is a right angle triangle and this is our 90-degree angle. So if this side have a slope m1 and this side has the slope m2. So m1 and m2 are the slopes of the line which forms the angle of 90 degree. Then the product of the slope, that is m1 into m2, will be equal to -1. Okay, that is, if we have any triangle and two sides satisfy the condition of perpendicularity, that is the product of the slope is -1, then it would be a right angle triangle. Okay, so this is how we are going to prove that these 3 vertices form a right angle triangle. Now let us start solving the question. So I assume that A is equal to 4, 4, B is equal to 3, 5, and C is equal to -1, -1. Okay. Then the slope of the line AB, suppose this is M1. It has nothing to do with this M1 and M2. So this will be equal to, applying the formula for the slope, that is M is equal to y2 minus y1 upon x2 minus x1, okay, which can be considered as the difference of ordinate upon difference of abscissa. So this will be equal to 5 minus 4 upon 3 minus 4, 3 minus 4. So this will be equal to 1 upon -1, that will be equal to -1. Okay. Similarly, here I should have written slope of AB. Okay. Now, slope of BC. Let this be equal to M2, and this will be equal to -1 minus 5. Okay, y2 minus y1 upon x2 minus x1. -1 minus 3. So this will be equal to -6 upon -4, or cancelling it by 3, I'm going to get here 3 by 2, because minus minus are going to cancel out and give me a plus sign. So this will be equal to 3 by 2. So slope of BC is equal to 3 by 2. Similarly, the slope of CA. Okay, CA. So let this be equal to M3, and this will be equal to, again, the difference of ordinate, that is 4 minus -1 upon 4 minus -1. That is the difference of abscissa. So this will be equal to 5 upon 5, and this will be equal to 1. It should be noted here that whenever we take AB, BC and CA, okay, in order, then we get the 3 sides of a triangle. So what we have done, we have calculated the slopes of the line joining A and B, B and C and C and A, that is the slope of the 3 sides of the triangle formed by these vertices, and we have named the vertices as ABC. Okay, now we see here is that M1 into M3 is equal to -1 into 1, that is equal to -1. Okay, so 2 lines are such, or 2 sides are such, that they satisfy the condition of perpendicularity. So this implies that the triangle is going to have one angle as 90 degrees, so it will be a right angle triangle. So you can write here, this implies that one angle is 90 degree in a triangle. Therefore, it is a right angled triangle. Okay, so this is how we are going to prove it.